Continuing on, now we talk about the next type of processes that are based on fusing uh, layers of powders. It can be metal, it can be ceramic, it can be polymers, etc. And this is the process in which thermal energy selectively fuses regions of powder bed. So these are the different variations of the process where uh, thermal energy is used. One is the direct metal laser sintering, or DMLS. You have electron beam melting, selective heat sintering, selective laser melting, and selective laser sintering. Selective laser sintering is the oldest technique among these, which was originally developed by a company called DTM out of University of Texas, Austin. It has now been taken over by 3D Systems. But you have also companies like Optomec, which are based on laser engineered net shaping, which is also a powder bed fusion technique. So in this process, you use either laser or electron beam to melt and fuse the material powder together. Most of these techniques require a vacuum but can be used with metals and alloys in the creation of functional parts. So among most of these techniques, this is one technique that has been used a lot to produce functional prototypes. So there's a lot of work going on all over the world in this field. And all these powder bed fusion processes involve the spreading of the powder material over previous layers. And there are different mechanisms to enable this, just like a roller or a blade. And sometimes you also use a wire feed system, just like Lockheed has been using for making parts for their satellite division. And there is a hopper or reservoir below or by the side of the bed that can provide the fresh material supply. So essentially you are depositing one layer, and then you use a roller to spread that powder, and then you melt it or partially melt it or sinter it to fuse the parts together. Then the process is repeated until the entire model is created. And then at the end, you have loose unfused powder. In this technique, you really don't use any kind of a support material, because the powder bed itself is used as the support material for this technique. So here is the powder bed, and if you go and look up GE's technique for making turbine blades, this is very much a powder bed fusion technique that they are using. So this is an example. So what kind of materials can be used? Nylon. If it is SHS, it is nylon. Then is DMLS, SLS, SLM, etc. You can use all varieties: stainless steel, titanium, aluminum, cobalt chrome, steel, and electron beam melting is titanium, cobalt chrome, stainless steel, aluminum, and copper. And the advantages are that you can make pretty large components and functional parts and large range of material options. But the disadvantage is at a relatively slow speed, although I disagree with that kind of a statement. I mean, I took this from a textbook or from a book, so I don't exactly agree with that, because the turbine blade that GE is making, they make one part in something like 7 or 8 minutes, and that is not slow. But sometimes, if you are making it, you may not always get the right kind of structural properties, or I would say it is more to do with structural properties that are isotropic. So you are probably not going to get isotropic properties because of the way the parts are built. You may have size limitations. So one advantage is that you can make parts parts in, components in parts, and then you can weld them together or you can machine them together, etc. Um, and the finish is dependent on powder grain size, and the smaller the grain size, the more expensive the powders. And again, just like all powder processes, this is a dirty process or not a very clean process. So here is a video of this process, and the other one is like it's a variation of this directed energy deposition, which is also like laser based. So lens would actually fall under this technique um, to melt and join the parts together. Or you can have directed energy deposition. So you can also have 3D laser cladding and things like that. In this case, it's a little bit more complicated terminology. So they claim that it is a more complex printing process. And one area where they are using it also is to repair or add additional material to existing components. So it's a slightly different variation of the whole 3D printing process itself. So here again, there are many variations of this and techniques. So here are some parts and the schematic and the machine that is used for building this process. And here are the step-by-step method for this process and some advantages and disadvantages. In this case, I mean, the typical process is that this cannot always, because you are using lasers to control the process. So sometimes you may not be able to use materials like aluminum or copper, which are pretty shiny. So you may have a little bit of issue using this piece of equipment for many of the components. So here is again some videos of the process, and what I want to end here is with, see, even though we are claiming about additive manufacturing and 3D printing and claiming that this is faster than traditional processes, traditional manufacturing process and things like that, this is still a slow process. So the way this process is, it is 3D printing, I mean, it is 2D printing in printing in 2 dimensions over and over again. But what is truly 3D printing? You have to make the whole part from scratch in one piece. Boom. So if you really want to see what we are talking about, you should go and look up this TED Talk on this YouTube video that shows, let me give you a hint, Terminator. So how the Terminator was built from, in one snap. So if you can make a part from a CAD model in one piece, in a very, very short time, that would be the ideal thing to do. So let me stop here, and this is the last talk of the lecture 3, and I will start posting the other lectures. I'll be posting this in the next day or so, and I will do the lecture 3 in the next couple of days. Thank you. Bye-bye.